In this Solutions and Aqueous Systems chapter unit, we actually combine chapter 12 and 13 together in the honors textbook. Chapter 13 talks about ions and aqueous solutions and their colligative properties. There's really only two parts that we're going to talk about in chapter 13 that we haven't already covered. The big one in chapter 13 is about dissociation, and then later on we have our colligative properties, which you'll see in the following video. So first things first, okay, what does it mean to dissociate? Okay, to dissociate means to separate into your ions. And all of you that love all of my ion stuff, it's never ever going away. We will always talk about ions and moles and stoichiometry. Okay, so if we go over the dissolution process where we have our solid crystals, like here our good friend NaCl, NaCl, salty, and the partial positive and partial negative nature, and we know that water acts like a piranha, which now I know how to spell. The piranhas are going to pull them all into solution. So if the formula for NaCl is NaNCl, how many ions do they produce? So that's where we start talking about this concept of dissociation factors. We're going to assume that we have 100% dissociation unless otherwise stated, which means basically we are going to have saturated solutions. And when we have saturated solutions, that means that 100% of what we start with is going to break up 100%. Okay, so NaCl, okay, is made up of Na and Cl. So if I have 1 mole of this, I will make 1 mole of sodium ions and I will make 1 mole of chloride ions. So the dissociation factor is 2. Why 2? Because it made 1 mole of NAs and 1 mole of Cl minuses, which means I have 2 ions for every 1 NaCl. So this has a dissociation factor of 2. Okay, calcium chloride, CaCl2, breaks up into Ca2 plus and Cl minus. But since it's CaCl2, we're going to see that there are 2 chloride ions. So this has a dissociation factor of 3 because we have 1 Ca2 plus and 2 moles of Cl minus. So this has a total dissociation factor of 3. And then I like to challenge people, what is the dissociation factor? Give me a second to write. For aluminum sulfate. What's aluminum sulfate, Levin? Oh, I'm glad you asked. Aluminum makes a 3 plus. Oops. And go back, delete. And SO4 2 minus. So again, if you don't know your ions, you don't know your charges. Gotta remember them. So this is Al2SO4 taken 3 times. So I have 2 Al3 plus aqueuses, and I have 3 SO4 2 minus aqueous ions. So what is my total dissociation factor? 2 plus 3? Dissociation factor of, you got it, 5. 5, 5. All right. Chapter 13 in the textbook is where they talk about the complete and net ionic equations for double reactions. Okay, so the complete ionic equation is going to be where we are going to break up anything that is aqueous into their ions and then leave anything that is a precipitate, a gas, or water molecule as is, and the gas is usually H2S gas. Okay, so this is all information that we have already gone over in Chapter 8. So if you want to refer to that, you have to look at the videos for Chapter 8 or our notes for Chapter 8. Okay, we have specific solubility tables and rules to figure out if we have an S or an I for soluble or insoluble. But that, my friends, is how you do dissociation factors.